Hi, in this video we'll discuss about power. So let's define what is power. So the rate of change of energy or work done is power. Now energy and work done are the same thing. They are considered as energy. They have same units, that is joule. And in energy it could be any form of energy. It could be kinetic energy, potential energy, elastic potential energy, thermal energy, or any sort of energy. So the rate of change of energy or work done is called power. So the formula for power is equal to energy over time. Energy over time, and the unit for power is watt, W-A-T-T, and we represent watt with capital W. We can also write the unit for power as joule per second. Alright, and in SI units, if we want to answer the unit of power in SI unit, it will be like kilogram meter square per second. Alright, so this will be the SI unit for power. This is the standard unit for power, watt. Now let's define watt. How much power will be equal to 1 watt? So if we come on to the definition of watt, so 1 watt is the amount of power. 1 watt is the amount of power that will be dissipated, by an object if it does 1 joule of work done. I'll write capital J because it's a unit of work done. 1 joule of work done in 1 second. So the power will be equal to 1 watt. Alright, so this is the definition for the unit of power, that is watt. Now the next topic that we will discuss is about the energy transfers in a system. So energy transfers in a system. We have discussed the systems before, and a system is an object or a group of objects. But now here, first of all, we will discuss about a closed system. So closed system. So a closed system is a combination of a single object or a multiple objects in which the total energy remains constant. The total energy of an object does not increase or does not decrease. For example, let's suppose we are considering a system over here where there is a ball. This is a ball at the ground. Now we exert some work done onto this ball, and this ball moves at some certain height h. Now we have done some work done onto this ball, and it has attained some height. Now because the energy at a specific height is called the gravitational potential energy, so let's suppose if we have done 10 joule of work done, then the whole work done will be converted into the gravitational potential energy. This 10 joule is the work done that is being done onto the ball, and this whole work done has been converted into the gravitational potential energy. So this is called a closed system in which there is no external energy transfers, or there is no energy transfer from within the system to the outside. So this is what a closed system is all about. Now from here we will discuss about the law of conservation of energy. So law of conservation of energy basically It explains about the transfers of energy. So I'll write here law of conservation of energy. This law states that in a closed system, the energy cannot be created nor destroyed, but it changes from one form to another. It changes from one form to another. So law of conservation of energy says that in a closed system, or I have forgotten writing system over here, so in a closed system, the energy cannot be created nor destroyed, but it changes from one form to another. For example, just the example that I gave you of the ball, that if you exert some work done onto the ball, it will attain some certain height, but the whole work done will be converted into the gravitational potential energy. So energy has been converted from one form to another, but it did not destroy it. All right, so now let's talk about the okay, let me give you an example. Let's suppose there's a ball. This is the ground. This ball is at some certain height. That height is h. Now this ball has some gravitational potential energy. Let's suppose the value of that gravitational potential energy is equal to 50 joule. Now when you release this ball from this position, the ball will move downwards. So the gravitational potential energy of this ball will be converted into the kinetic energy of the ball. Why? Because the ball has started its motion. So the energy possessed by an object during its motion is the kinetic energy. So when you release this ball, the whole 50 joule should be converted into the kinetic energy. Just before hitting the ground, over here, this ball will have maximum kinetic energy. Why? Because all the gravitational potential energy has been converted into the kinetic energy. But here, instead of 50 joule, the kinetic energy is 45 joule. The rest of the 5 joule of energy has been wasted. Now where did it waste? That energy has been wasted within its journey from this position to this one, and that wasted energy is due to the air resistance. The air resistance will be upward and the ball is moving downward, so that air resistance will create some heating effect, and the 5 joule of energy will be wasted in the form of thermal energy and some sound energy as well. Thermal energy and sound energy. So that 5 joule has been converted into the thermal energy and the sound energy. So that thermal energy or the sound energy is of no use to us, so that we will consider that thermal and sound energy as the wasted energy. So whenever one form of energy is converted from one form to another form in real life, there will always be some wasted energy, and in most cases the wasted energy is in the form of thermal energy and the sound energy. All right, now what are the ways in which we can reduce that wasted energy from the system? So let's discuss those ways in which we can protect our energy from being wasted. All right, so I'll write it over here. The ways to reduce the wasted energy. Now over here, I just as I told you that the wasted energy is in the form of thermal energy and sound energies, but in most cases it is thermal energy. So let's suppose within the engine of the car, the parts are rubbed with each other. There's friction between the engine of the car. So if there is not proper lubrication within the parts of the engine, there will be so much energy that will be wasted in the form of thermal energy that will wear out the engine of the car. So the number one thing that we can use to reduce the wasted energy is the lubrication. We should lubricate all the parts of the machinery that are being rubbed with each other. This lubrication can be done in any machinery, like in any machinery, like in factory, in motors, in engine of the car. All right. The next way to reduce the wasted energy is to transfer the energy from the place where that is too hot to some another place. Let's suppose there is some furnace. This is a hot furnace. So what we do here, we want this hot furnace temperature to remain at some constant temperature. So let's suppose if its temperature exceeds a certain value, so we have to transfer the thermal energy from this hot furnace to some other region. So what we do is we attach some metal rod with this hot furnace, and we put that metal rod into some water, some cold water. So what will it do? The heat will be transferred from this metal rod from the hot furnace to this water with a process that is called conduction. We know that metals are good conductors of heat. So we put the metal over here, and that metal will transfer the heat energy from the hot furnace to the water, and this hot furnace will remain at a constant temperature. So in this way we can reduce the wasted energy from this hot furnace. Or another way, we can use that energy to heat up the water as well, and that water can be used for some other purposes. Now similarly, when there are some buildings in summer season, they become so hot, so we have to keep an eye on the thermal conductivity of the walls of the building. So we should the more thicker the walls of the building are, the less heat will be transferred with to the building. So in order to keep the building cold, we need less expenses. Similarly, so the thickness of the walls will play their role in order to maintain the temperature of the building at a constant level at a constant level. So by varying the thickness of the walls, we can increase or decrease the wasted energy that is used to cool down the building. So these are some of the ways in which we can reduce the amount of wasted energy in any closed system. Now in order to check how efficient is the closed system is, we discuss another concept that is called efficiency. Now efficiency tells us about the performance of a closed system, which means how much the system is wasting the energy and how much it is using the energy in a useful manner. So efficiency is basically the ratio of the output energy or power to the input energy or power. Instead of writing output, we will write here useful. So the ratio of the useful energy or power to the ratio of input to the input energy or power is called the efficiency. So efficiency does not have any unit, and the formula for efficiency would be that efficiency is equal to useful energy over total energy, or we will write here input energy, times 100. So this formula will give us the efficiency in the form of percentage. All right, and if we want to, we can also find out the efficiency in terms of power. So if we want to explain the efficiency in terms of power, we will just replace energy with power. So useful power over input power times 100 will give us the efficiency in percentage. Now, if a system is efficient, it will waste less and less amount of energy, and it will convert maximum input energy or input power into useful energy or useful power. But in reality, no system is 100% efficient. But in an ideal case, we take all the systems to be 100% efficient. But in reality, the efficiency will always be less than 100%. So this is it for this lesson, and hope to see you in the next lesson. Thank you.